Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values of the function f of t equal t plus cotangent of t half on the interval pi fourth 7 pi fourth. So first we're going to remember the definition of cotangent of t half. We know that that's 1 over tangent of t half. And because tangent of t half is sine of t half over cosine of t half, we will have here t plus cosine of t half over sine of t half. It means that the function is defined whenever sine of t half is not 0. But in this case, t is in the interval from pi fourth or through 7 pi fourth. And that means that pi fourth is less than or equal to t less than or equal to 7 pi fourth. That means that pi eighth is less than or equal to t half less than or equal to 7 pi eighth. And we know that this value here, pi eighth, is positive, of course, because pi is a positive number, 8 is a positive number, and this is less than pi because we have a multiple with a scalar 7 over 8, which is less than 1. So we have this inequality that means that when t is in this interval, as is the case in this problem, the argument of the sine of t half, the argument of sine of t half in this denominator here, that argument is between 0 and pi, but is never equal to 0 and never equal to pi. So sine of that argument t half is like the graph of the sine function, but a little bit after 0 and a little bit before pi. That is, here is 0, here is pi, let's say. And so the graph of the sine of t half will be something like this. It never reaches 0 either way, near 0 or near pi. So we can say that sine of t half is positive for all t in the interval from pi fourth to 7 pi fourth. So that's the first thing, that is, this function is well defined. That is, the cotangent of t half never gives an undefined or non-finite number. But also we know that because of that, the function is continuous on the interval given here. So f is continuous on pi fourth 7 pi fourth, for the same reason that this expression here is continuous. T is continuous, cosine of t half is continuous, and this expression is continuous, and the quotient of the two expressions, cosine of t half and sine of t half, is continuous because the denominator, sine of t half, never is equal to 0. So this expression is the whole function f of t is continuous on the closed interval pi fourth 7 pi fourth. And for that reason, being continuous the function and close the interval, we know that f attains its extreme values. on the given interval. It means there are points or values in this interval for which the image of those points are equal to the extreme values of the function. We also know that these extreme values are attained at either the endpoints of the interval or at critical numbers of the function. So we gotta find the critical numbers of f, and for that we calculate first the derivative of f, and this is equal to 1 plus the derivative of cotangent of t half, that is negative cosecant square of t half times the derivative of t half is 1/2. So we get 1 minus 1/2 of cosecant square of t half. And that's equal to 1 minus cosecant square is 1 over sine square of t half. So we get 1 over 2 sine square of t half. And we know already that this, as we said before, this expression sine of t half is never 0 for t belonging to the interval pi fourth and pi fourth. That's what we see here. And for that same reason, this derivative exists for every value of t in the interval pi fourth, 7 pi fourth. And that's simply because the denominator, 2 sine square of t half, is never 0. And that's because sine of t half is not 0 for t in this interval. Because sine of t half we studied over here. And we saw it's never 0 for t on the interval pi fourth, 7 pi fourth. So if this derivative exists for every value of t in this interval, it means then that the only critical numbers of this function in this interval are those values of t for which the derivative is 0. So we can write that now. So we have this, and we got then to solve this equation. That is, we start with the derivative of f is equal to 0, and that's the same thing as using the formula of the derivative, which is this one here, 1 minus 1 over 2 sine square of t half is 0. This is the same as 2 sine square of t half equal 1. And this is the same as sine square of t half equals 1/2. And this is even equivalent to sine of t half equal more or less 1 over square root of 2, which is equal to more or less square root of 2 over 2. So this is the equation we're going to solve, and we know the sine of some angle is equal to square root of 2 over 2. The angle got to be pi fourth. But there are two angles that solve this. Well, first of all, let's put things in perspective. We have two equations here: sine of t half equal square root of 2 over 2, and sine of t half equal negative square root of 2 over 2. But we saw here, we said it just here, that sine of t over 2 is positive for t in the interval pi fourth, 7 pi fourth. That's what we saw here up. Because t half for t in the interval pi fourth, 7 pi fourth, t half is strictly positive and less than pi. So we have this situation: the sine is always positive, never reaching the value 0. So sine of t half is positive. So this equation is in reality only one equation, not two, because the negative sign has no sense for t in the interval negative pi fourths and pi fourth. Let's say it again here. Since this is positive for all t in the interval, only have to solve the equation sine of t half equal square root of 2 over 2 for t in pi fourth 7 pi fourth. So now we get to look a little bit at the graph of sine of x, that is the sine function. Again, remember is something a little bit like this. 0, pi, 2 pi. And as we are here, we know that we only need this part of the graph, that is, we don't need this part here, and so we stay right here. And we are looking for the angle whose sine is square root of 2 over 2. Let's say square root of 2 over 2 is something like here. And then we have two solutions, even for angles between 0 and pi. We know exactly that t half is between pi eighth and 7 pi eighth. So we're going to solve the equation first and see if we are inside this range. But at least between 0 and pi, which is this graph here, we know that there are evidently two solutions for this equation. This angle here, which we know is pi fourth, that is the argument of the sine function, gotta be pi fourth. And we gotta know which is this other solution. So the solution is with respect to pi half, which is this value here, where sine is equal to 1. We know that this distance here is the same as this distance here. So we gotta say that we have 1, 2, and 3 pi fourth. So it's 3 pi fourth, the other solution. And that's the value that must have the argument of sine in order to sine be equal square root of 2 over 2. So looking at that graph, we say that t half, which is the argument of sine function in this equation, got to be equal to pi fourth, or t half got to be equal to 3 pi fourth, which is the other solution here. Okay, so from this, t got to be pi eighth. Sorry, not pi eighth, because if we multiply by 2 both sides, we get pi half. Or t got to be multiplying by 2 both sides is 3 pi half. And we see that these two values are inside the range given up here, between pi eighth, which is smaller than pi half, and 3 pi half is smaller than 7 pi eighth. So we are inside the intervals without problem. You can also see it in the way that now we have the values of t, and t is between here it is between pi fourth and pi fourth, and we know that pi half is greater than pi fourth, and 3 pi half is less than 7 pi fourth. So we are good here. So both of these are critical numbers of the function inside the given interval. Then there are two critical numbers of f within pi fourth, 7 pi fourth. They are t equals pi half and t equals 3 pi half. These are the two critical numbers of the function. There are no more critical numbers because these are the only solutions to the equation f derivative of f equal to 0 for values of t inside the interval pi fourth and pi fourth, and the derivative exists in all points of that interval, meaning that the only critical points are those for which the first derivative is 0, and then being these two the only solution to that equation, f derivative of t equals 0, they are then the only critical numbers of the function. Okay, so we got to evaluate the function at the critical numbers in the interval here, and that is at these two values, and at the endpoints of the interval, that is pi fourth and 7 pi fourth. We have to evaluate f at these two critical numbers and at the endpoints of the interval pi fourth, 7 pi fourth. That is, get to evaluate the function at pi fourth and at 7 pi fourth. And between those four values will be, or will have, the extreme values of the function. So the largest value will be the absolute maximum value of the function on the interval pi fourth and pi fourth, and the smallest of the values will be the absolute minimum value of the function over the given interval. Okay, so we start by evaluating the function at the endpoints. Let's say f at pi fourth, at the left endpoint. So by definition is pi fourth plus cotangent of pi fourth over 2, that is pi eighth. And that's equal to, is rather approximately equal, not equal. It's rather approximately equal to, using a calculator, 3.20. Now we evaluate f at the writing point, 7 pi fourth, that is 7 pi fourth okay, let's put it correctly here, 7 pi fourth plus cotangent of 7 pi eighth, because remember the cotangent is evaluated at t half. So here is 7 pi fourth half is 7 pi eighth. And that's approximately equal to 7 pi fourth plus cotangent of 7 pi eighth. Using a calculator, we find 3.08. Now we calculate f at the critical numbers, pi half and 3 pi half. So let's start with pi half. That's pi half plus cotangent of the half of this value, that is pi fourth. We know the cotangent of pi fourth is 1 over tangent of pi fourth, that is 1. So this is exactly pi half plus 1. And to have a reference of comparison with the previous values, this is approximately equal to 2.57, and f at 3 pi half is pi half, 3 pi half, plus cotangent of the half of this, that is 3 pi fourth, and that's equal to 3 pi half, and we know cotangent of 3 pi fourth is negative 1, so we get this value here, which is approximately equal to 3.71. And so the largest value will be the absolute maximum value of the function over the interval. The largest value here is this one here. So this is the absolute maximum value of the function. That is exactly 3 pi half minus 1, and is attained at the critical number 3 pi half. And now the smallest of the values is this one here. That is exactly pi half plus 1. Then that will be the absolute minimum value of the function over the given interval, and is attained at the other critical number, pi half. So we can write the answer to the problem. So the absolute minimum value of f on the interval pi fourth, 7 pi fourth is pi half plus 1. Let's write it properly here. Pi half plus 1, which is about 2.57, and that value occurs at the critical number t equal pi half. Now we go for the absolute maximum. So the absolute maximum value of the function f on the closed interval pi fourth, 7 pi fourth is 3 pi half plus minus 1, which is approximately equal to 3.71, and that value occurs at the other critical number of the function, t equals 3 pi half. So this is the final answer to the given problem, and we recall what we did here. So first of all, we analyze a little bit the function in order to see that it is well defined, and also it is continuous on the given closed interval, and for that reason we know that the function attains its extreme values, and we also know the extreme values are attained either at the endpoints of the closed interval or at the critical numbers of the function in that interval. We calculate the first derivative, and we obtain an expression which is never undefined, that is, exists for every value of t in the given interval, and that's because the denominator is just sine of t half as in the definition of the function. So we've proved or verified above that this denominator is always positive and not zero. So that's why we arrived to apparently two different equations we have to solve, but in fact it's only one because the negative sign cannot be considered because the function sine of t fourth and sine of t half is positive for all t in the given interval. So we have to solve only one equation, and the solution to the equation are in fact two solutions for t between pi fourth and 7 pi fourth, and these two solutions are t equal pi half and t equal 3 pi half. So we have two critical, and they are both in the given interval. So there are only two critical numbers of the function in the interval pi fourth and pi fourth, and they are pi half and 3 pi half. So we got to evaluate the function at those critical numbers and at the endpoints of the interval pi fourth and 7 pi fourth. We did that, and the largest value found was the image of 3 pi half, that is the image of one of the critical numbers, and then that largest value of the four calculated is the absolute maximum value of the function over the given interval, and the smallest of the four values was pi half plus 1, which is the image of the other critical number pi half, and then that's the absolute minimum value of the function over the given interval. And then that's the answer to this problem.